This video is how to write chemical equations. You can use this for just writing anything that needs to be balanced or for limiting reactant problems as well. So the first thing you need to remember is different types of reactions because you might have to predict some of these. So the first type of reactions is a combination reaction. So if you have something like sodium and it's reacting with bromine, these things are going to smack together and you're going to get NaBr. You need to look at the charges on your periodic table. Sodium has a 1 charge, bromine has a -1 charge, and those charges cross, so we get NaBr. And then you would need to balance this equation, so we would need a 2 and a 2. And do remember we do have our 7-up rule, which is where this 2 comes from. So when the following elements are by themselves, they will get a 2. That would be hydrogen, that's our up. Then we got nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, right? 7 up. So when any of those things are by themselves, they will get a 2. Second type of reaction is a decomposition. You often wouldn't have to predict these because they're a little more tricky to predict. But it is just one thing breaking down, and usually it will break down into some kind of oxygen and then your other 2 elements. And again, you would need to balance this equation. Third type of reaction would be a single replacement. In a single replacement, you have one item by itself, and it is trying to attack or react with something else. So the metal is going to attack the metal. Remember to check the chart on the back to see if it's possible. If you're writing the equation, it probably will be possible, but that kicks out that element and puts it by itself. And now the metal is with whatever that non-metal is. Again, anytime something's bonded, you need to check the charges. We have a 2+ and a 2- charge, so those end up canceling out. So it's just FeCaO. So to balance this, we will need a 3, and a 2. Fourth reaction is a double replacement. This one is the trickiest and has the most types of charges. So let's say that we had some aluminum nitrate and it is reacting with some potassium carbonate. So when looking at these, the end of the equation has an 8 in it on both of these. You can find those as polyatomic ions on the back of your periodic table. So aluminum has a 3+ charge, nitrate has a 1- charge. This is going to be AlNO3, 3. So the 1 and the 3 are going to cross charges there. And then we have potassium carbonate, 1+ charge and 2- charge on the carbonate. That gives us K2CO3. So remember, those charges cross. Okay. So once you have the original part written, this is a double replacement. So the first 2 elements are going to switch. Those 2 positive cations are going to switch. So now you're going to get K with NO3, and you're going to get Al with CO3. And you need to look at charges on everything. So 1+, 1-, those are good. 3+ charge, 2- charge. So that's going to be Al2, CO3, 3. Okay, so this is all written correctly. You would then have to balance that. So we would need a 2, a 3, and a 6. Last type of equation is a combustion. That's any time you have something with a CH and some oxygen, they're always going to make the same thing, carbon dioxide and water. So that was a quick kind of predicting the products reminder there. I'm going to do a couple more, just how to write different equations. So this first one says we have 12 grams of oxygen reacting with 15 grams of aluminum to make what mass of aluminum oxide? Determine the limiting reagent. So if you have 12 grams of oxygen is O2 because it's part of 7-Up, and that is reacting with aluminum, so that's just Al. So this is going to be a combination reaction. So aluminum is going to be with oxygen. We need to look at the charges here, 3 plus, 2 minus, you cross those charges, Al2O3. Then you also do need to balance this equation. So we would put a 2 here, 4 here, 3 there. So once you've written your equation, then you can go ahead with your 2 different values, and you can convert those both into moles. Then you would need to do your mole to mole, and then you can convert into grams of Al2O3. Again, whichever one is smaller is your limiting reagent. Okay, this one says we have some calcium nitrate reacting with some sodium phosphate. Calcium has a 2 plus charge. Nitrate has a 1 minus charge, so it's going to be CaNO3 2. Sodium has a 1 plus charge, phosphate 3 minus charge. It's going to be Na3PO4. This is a double replacement reaction, so Ca and Na are going to be switching. So this is going to be NaNO3 with CaPO4. Again, you have to look at the charges of everything. You can't just write the end there. So those both have a 1 charge, so that's good. This has a 2 charge, that has a 3 charge, so they cross. That's going to be Ca3, PO4, 2. And once you write that, we're going to need to then balance it to finish this up. So we have 3 calcium, so we need a 3, 2 phosphates, so we need a 2, and then we need a 6 on that sodium nitrate.